My name is Dr. Sunghamindira Devi. I'll be teaching chemistry for class 11 and 12. Hello everyone. Today, let's take up a new unit, Unit 3, Electrochemistry. The main objectives of learning this unit are to describe an electrochemical cell and differentiate between galvanic and electrolytic cells, to apply Nernst equation for calculating the EMF of galvanic cell and define standard potential of the cell, to derive relation between standard potential of the cell, Gibbs energy of cell reaction and its equilibrium constant, define resistivity, conductivity and molar conductivity of ionic solutions, to differentiate between ionic or electrolytic and electronic conductivity, to describe the method for measurement of conductivity of electrolytic solutions and calculation of their molar conductivity, to describe the method for measurement of conductivity of electrolytic solutions and calculation of their molar conductivity, to justify the variation of conductivity and molar conductivity of solutions with change in their concentration and defined molar conductivity at zero concentration or infinite dilution, to enunciate Coulom's law and learn its applications, to understand quantitative aspects of electrolysis, to describe the construction of some primary and secondary batteries and fuel cells, to explain corrosion as an electrochemical process. अखोई हुजी electrochemistry हाइबसी करिनो हाइना खंगनबा नैनासी, the branch of science that deals with the study of all chemical and physical processes in which electricity is either produced or consumed is called electrochemistry. Lower class ta अखोइना electrochemistry सिगी basic concept की मतंग दसु नैना खरबनी अदुबो अखोई हुजी अमु मसीदा सिजिन्नबा terminology खरसिंग अमुसु नैनासी. Electrical conductors. Electrical conductors हारगदी those substances which allow electricity to pass or to flow through them. खुदम मोइना पियु हारगदी अखोइना metal सिंगसी, these are good conductors of electricity हाइना हाइ. Then metal सिंगसिदा मरुइना अखोइना यामना सिजिन्नरिबसी copper, aluminum, iron yan maruina sijinai amadi hariba metal singasina tongan ba proportion da yan salaga semba brass, bronze, steel singasisu electrical conductor ngaktani. Diagram asida mafam asida aikoina electrical wiring da yan toina sijinaba aluminum wire, copper wire utli amadi electrolyte sing yawa solution sing खुदम मोइना copper sulfate solution, magnesium sulfate solution, siguma sing asisu electrical conductor oina sijinai. Then insulators. Insulators are those substances which do not allow electricity to flow or to pass through them. खुदम मोइना इखोइना wood, plastic gumba, porcelain gumba, insulator mayam sijinai mafam asida electrical appliance sing the sijinaba हाइदी wood asina एकोन insulator ओइना सिजिनाबसु ओली अमदी electrical wiring fitting mayamam da सिजिनाबा porcelain insulator su ओली लोइना ना plastic insulation su ओली. Now let's go to two types of conductor मखलानी लाई metallic electronic conductor हाइबा मा नत्रगा electrolytic conductor हाइबा मा हजिक एखोइना अनि सिंग अदु अमु हाइपेट नैना हौसी. Metallic natraga electronic conductors singsidadi maruina generally they are metals, metalloids and alloys of metals and some metal oxides. Then in such type of conductors the current carriers are electrons and they may be classified as good and poor conductors, and it depends upon the nature of the metal, number of valence electrons and temperature. Then let's analyze about electrolytes or electrolytic conductors. Electrolytic conductors sing generally acids, bases, salts sing habdi ion oina pithokpa ngamba makhoi sing asibu aikoina electrolytes oina lawi they conduct electricity either in molten state or in aqueous state. And in such type, current carriers are ions, and they may be classified as weak and strong electrolytes, and it depends on the nature of the electrolyte, nature of solvent, solvation or hydration of ions, its degree of dilution, temperature, etc. Now, mafam asida ikhoina amuk degree of dissociation nataga degree of ionization sigi concept khara amuk khanghosi haiba degree of dissociation se koi alpha na signify tawi. It is the ratio of the molecules of the electrolyte which split into ions to the total number of molecules of the electrolyte. It gives the conducting power of the electrolyte. Hairiba alpha asi khangnaba matungda electrolyte adugi conducting power khangani. Mafamasida ikoina alpha asi, it is the pure ratio. Karipi number of molecules of the electrolyte that splits into ions by total number of molecules of the electrolyte. Adu aragadi if alpha equal to 1 haragadi kari oini number of molecules of the electrolyte that splits into ions. Ionized tokiba number of molecules siga total number of molecules siga manai haibani haibadi haiba molecules singa ikona solution da lorisi completely ionized tokre, completely dissociate tokre haibani. Adu aragadi asumna alpha gi value si 1 oiba matamda lowriba electrolyte adu strong electrolyte oigani. Aduga if alpha is less than 1, aduidi ionization takes place to a lesser extent and it becomes a weak electrolyte. Now let's discuss about the electronic concept of oxidation and reduction. Akoi hanasu tamkre aji amu nainasi akoi na khangre hanasu. Oxidation is the process in which an atom or ion loses one or more electrons, whereas reduction is a process in which an atom or ion gains one or more electrons. Adu eragadi ekoini hojik masida mu oxidizing agent, reducing agent haina ani amu khaidorakani. Reducing agent hairagadi hairiba process sida masamak electron di loss tauba haibidi masamak chi oxidation sathaba aduga magi presence na maram oiduna atopa species amada reduction to halagadi haibe species adubu wai khoina reducing agent haina khangnai aduga mu atop amaromda species karamba species masamangna electron di gain tauba haibidi reduction sathaba adubu magi presence ta maram oiduna atopa species amada oxidation jatha lagadi haibe species adubu wai khoina oxidizing agent haina khangnai. Matungda mu khoi redox reaction haragadi redox reaction se ai khoina oxidation reduction reaction haina su khangnai. So an oxidation reduction or redox reaction is a type of reaction that involves transfer of electrons between two species in which one undergoes oxidation while another species undergo reduction simultaneously. Haji akhoi redox reaction gi example ama illustrate tauri. High reaction na sida phangi basi zinc. Zinc na reacts with hydrogen ion. Generally hydrogen ion se acid tagi lakali. Zinc reacts with hydrogen ion to give zinc ion and hydrogen gas. Reaction sida khoi yengsi oxidation half reaction. Oxidation half reaction matam sida kanano oxidize tawi zinc sina electron ani se mangaba matungda ionize tawi zinc ion oina masibo khoina oxidation half reaction haina khangnai. Then reduction half reaction haragadi sida yariba hydrogen ion acid yariba hydrogen ion sina electron losalaba matungda electron accept tora matungda mu hydrogen gas only masibo khina reduction half reaction haina represent tawi. Adu eragadi overall reaction sida pireba overall reaction sida oxidizing agent kanano reducing agent kanano mu yengsi aikhoina reaction asigi matungina hydrogen ion asi oxidizing agent ya haigani karigi hydrogen ion se masamakti reduction chathai adubu magi presence na maram oiduna zinc asina oxidation chathai amara maduna hydrogen ion si ekoina oxidizing agent haini. Likewise, zinc asimu ikhoina reducing agent hai. Kari maramgi zinc yaubuna maram oiduna masamakti oxidation chathaba. Aduga magi presence da maram oiduna hydrogen ion sing asina amu reduction chathai. Maram aduna ikhoina zinc asi reducing agent haina haigani. Mathangda ikhoi amu electrochemical cell gi maram da khangnana ba mung naina si. An electrochemical cell is a device capable of either generating electrical energy from chemical reaction or using electrical energy to cause chemical reactions. Masida mu makhal ani lei galvanic cell haiba ma amadi electrolytic cell haiba ma. Ekoi hojik galvanic cell asi mu khangnaba mu yengsi. Galvanic cell asi magi atopa maming amana ekoina voltaic cell su kawi. Masibu cell asibu galvanic cell haribigi maramdi hariba cell asi ihan hana L galvani na 1718 da putoklami. Adugi matungda amu voltaic cell na haribigi maramdi hariba cell asibu amu re-innovate tauba habidi akara improvise tauba kanana A voltana 1796 te improvise tauki maramaduna ekoina masibu galvanic cell natraga voltaic cell hanis khangnai. Then, a galvanic cell is an electrochemical cell that converts electrical energy of a spontaneous redox reaction into electrical energy. Aikoi huji galvanic cell amagi essential part sing amu naina si. Galvanic cell amada aikoina electrode ani yaugani. Hariba electrode ani asi samanabi electrolyte ama natraga tungan ba electrolyte amada lupsali. Karigumba aikoina electrode ani adu amu atopa conducting wire amana join tawba matam sida hariba samjanaraba matung sida electrode amadi electrolyte sing dugi marakta tungan ba subtle chemical reaction khara thoi. Then transfer of electrons from one electrode to another takes place, and such types of reactions is known as electrode reactions. Asiguma reaction asida amuk aikoina kari khangbangami asumna electrode anidu wayana samjanba matam sida transfer of electrons haibadi between the electrodes ti transfer electron transfer tawi electrode amana atope electrode amada electron supply tawi aduga amu another electrode amana supply toribe electrode to amu lawshali asumna sa thaba matamda the electrode which undergo oxidation is called anode, whereas the electrode which undergo reduction is called cathode. Then, haji amuk half cell abisi amuk kaino yengsi. Haji hai kre electrode amasi electrolyte amada tungana lusan ba nataga same electrolyte amada lusan basu yai hai kre. Aduna di combination of an electrode with an electrolyte is called a half cell. Galvanic cell amada generally half cell ani yaugani amana kari cathodic half cell atopa amana anodic half cell. Cathodic half cell asibu aikoina reduction half cell haina zu khangnai aduga anodic half cell asibu aikoina oxidation half cell haina zu khangnai. Hariba galvanic cell asigi typical cell asi aikoi Daniell cell explain tausi haji aikoi construction and working of a Daniell cell yengsi. Mafam asida aikoina Daniell cell gi diagram ama utli masi yengaga naina si. Daniell cell amada yauribasi aqueous solution of zinc sulfate and copper sulfate having molar concentration say 1 molar. Haiba aqueous solution ani se zinc sulfate copper sulfate ani si tungan ba glass beaker ani da laurani. Hariba zinc sulfate tudana zinc rod ama lupsalaga thamgani. Then copper sulfate na either copper rod natraga copper plate ama lupsalaga thamgani. Zinc rod asina anode oina ek tawi amadi copper rod sina cathode oina ek tawgani. When the two electrodes are connected to a voltmeter or a ammeter through a wire, then the two half cells are also again made to close using a solvers. Hariba anode amadi cathode ani adu aikoina wire amana voltmeter natraga ammeter amagi through the samlaba matungda cell asibu circuit asibu phajana close to busi ekhoina sol bridge amana hairiba half cell ani dubu ekhoina connection to hali haji ekhoi hairiba Daniell cell ase completely set up tawre haina loro matung sida maduda sathariba ekhogi process mayam observation mayam asi yengsi asumna circuit ase close to matamda voltmeter do ekhoina deflection towards left the deflect over ugani masina kari tai masina takpadi current flows towards the left the deflect oridina current si left the cell haibani that means amu in the reverse sense electrons flow towards the right in opposite direction mathangda during the process zinc rod gradually loses weight kaidobagi zinc sina kaidoge habada electron ani pitho matungda zinc ion da ionize tawi amadi hareba zinc ion singdu ionize toro matungda solution da satki asumna taw matam sida zinc singsina masagi weight hantarei amadi solution singda yawriba zinc ki concentration hengalai. In the same way, copper da amu kaidogani copper dana amu weight gain tawgani haibadi reduction sakhagani zinc dagi loss to khrabe electron singdu external circuit ta wire da chala matungda copper na gain tawgani amadi copper sulfate solution da yariba copper ion singdu discharge toro matung sida amu copper ino on khigani amadi copper singsina weight gain tawgani adugo loina na copper sulfate ki concentration du hantarakani then zikta haikre the concentration of the zinc ion in the zinc sulfate increases while those of copper ions in copper sulfate decreases adumoina the two half cells remain electrically neutral aikoina sol bridge ama hapaduna maram oiduna sol bridge sidasu tongamba ion kaya sol kaya yauri haiba sol bridge da yauri ba ion singsi solution ani duda zinc sulfate amadi copper sulfate solution da with respect to time supply torai maram aduna the two half cells say it remain electrically neutral then there is no evolution of heat during the process then the reaction as well as flow of electrons will stop after some time. Adu agadi aikoi hoji hairiba Daniell cell se jathaba oxidation half cell amung naina si aikoina Daniell cell sida haikre zinc atoms from the anode after losing 2 electrons each gets oxidized to zinc 2 ions which then moves in the solution and then the oxidation half reaction si zinc china kaidoi it gives zinc 2 ions by losing 2 electrons and then reduction half cell da the electron that released by the zinc in migrates towards the cathode through the connecting wire then these electrons are taken up by the copper 2 ions in copper sulfate solution and then are reduced to copper and thus copper gets deposited at cathode. Masibo koina reduction half cell oina mafam sida represent tawi copper 2 plus it gains 2 electrons to give copper solid and then the overall reaction is zinc reacts with copper 2 ions to give zinc 2 plus ion and copper solid copper adu agadi hojik hairiba Daniell cell reaction ekhoina pikiba cell reaction adugi cell representation amu yengsi cell reaction mafam sida leire zinc solid zinc reacts with copper 2 ions from the solution to give zinc 2 ions in solution and copper solid cell representation da ekhoina yengsi ekhoina Daniell cell yakpa matam sida generally anode na oirom da thamgani cathode na yelom da thami adu agadi cell representation sidasu likewise ekoina vertical line ani uli vertical line ani sigi oi thangba sina amu kari oirani ekoina half cell amani karamba half cell anodic half cell ye thangba da lairi sina amu cathodic half cell ni hariba ekoigi vertical line ani sina ulebasi sol bridge dubu khangali amadi oi thangba side ta koi half cell du yengsi half cell si dai koina hana mamangda zinc sina electron ani manga matungda zinc to ion da oli hairiba electrolyte interface asi mafam asida ikoi single vertical line amana oli. Likewise asomda copper 2 ion solution da yawba aduna electron anise gain tor matungda solid copper da onba madugi electrolyte interface su mafam sida oli natraga ikoina cell representation sibu achama mawongda concentration du yawraga asumna makhage asumna ibasu yai. Now let's analyze functions of Soul breeze. Soul breeze karino? A soul breeze is an inverted U-shaped glass tube which contains a thick paste of salt, generally potassium nitrate, potassium chloride, even sodium chloride and it is made in agar-agar. Now, the main functions of the soul breeze are: it completes the inner circuit, it prevents transference of the electrolyte from one half cell to another, and then it maintains electrical neutrality of the electrolyte in the two half cells. Let's analyze some typical electrodes. Electrodes singshida ikoina metal ion electrodes. Mamangda ikoina Daniell cell sizinarkebadu metal ion electrodes ni. Metal ion electrodes asida kaidauge haibada metal rod adu masagi electrode allied amta lupsalaba matungda madubo ikoina adumna sizinaba electrode adubu metal ion electrode haina khangnai. Mathang yesina ikoina standard hydrogen electrode SIE asumna khangnai. Standard hydrogen electrode ki diagrammatic representation ama mafam asida piri ikoi yengsi. It consists of a platinum wire coated with finely divided platinum, also called platinum black, and it is sealed in a glass tube and a platinum foil at one end. See, coating this coating helps to absorb hydrogen and establish an equilibrium between the molecules of hydrogen and hydrogen ion in solution. The wire, it is then dipped in an aqueous solution of hydrogen ions, generally 1 molar hydrochloric acid. After that, setup toromatungda kaidawni pure hydrogen gas of 1 atmospheric pressure is constantly bubble through the solution at 298 Kelvin haina asumna pressure na 1 atmosphere amadi temperature na 298 Kelvin da maintain tauraba standard hydrogen electrode amagi diagrammatic structure ni mafam asida piri hairiba electrode asigi cathode Sathabar cell representation, anode Sathabar cell representation mafam sida piri. Amadi masigi electrode reaction sida hydrogen ion sina electrode se accept tauraga reduction sathara matungda half molecules of hydrogen gas phangi. Then the reverse the case is in terms of oxidation. Hariba electrode asibu aikoina reversible electrode haina su kawi karigi. This electrode can be used both as an anode and as a cathode. It has some limitations. Standard hydrogen electrode ki limitation khara khaktang som khangmi nasi. Aikoina mamangda haikre hairiba electrode asida pressure asi 1 atmosphere da standardly maintain tawi haidana. Adubu maintaining such a pressure of 1 atmosphere is a problematic one. And another one is difficulty in keeping the concentration of hydrogen ions is 1 molar. Another is very important one, platinum, which is the very important part of the electrode. Say it can be easily poisoned even by small traces of impurities present. Haji aikoi mathangda kilomen electrode chi khangnaba mung naina si. Kilomen electrode asida yaurabasi it consists of mercury, maruina mercury ni in contact with kilomen. Kilomen haragadi mercurious chloride. Adunadi amuk a solution containing chloride ions. Kudamoina potassium chloride kumasi amuk adudamu is then poured over to it. हाइरिबा केलोमेन इलेक्ट्रोड की डायग्रामेटिक रिप्रेजेंटेशन सु मफम असिदा पीरी अमदी हाइरिबा इलेक्ट्रोड असिना रिडक्शन ओइना as well as oxidation oina sathaba anode oina cathode oina ek tawbagi representation su mafam sida piri amadi reaction su piri yengsi hoji reaction sida calomel asina mercurius chloride asina electron se loction laga reduction satharaba matungda mercury amadi chloride ion na puthui hariba mercury amu chloride ion sina reverse the reaction da amu हाइरिबे इलेक्ट्रॉन सी पिथोअबा मतुंग सिदा ऑक्सीडेशन चथदुना अमु मर्करियस क्लोराइड से फॉर्म तवी हाइरिबे रिडक्शन ऑक्सीडेशन असिगी रिवर्सिबल प्रोसेस असि अबमसिदा पीरे नेक्स्ट लेट्स ट्राई टू अंडरस्टैंड स्टैंडर्ड इलेक्ट्रोड पोटेंशियल ई नोट एंड सेल ईएमएफ अहान बदई कोई इलेक्ट्रोड पोटेंशियल नत्रगा रिडक्शन पोटेंशियल है नजु खंगनबा मसी कईनो मु येंगसी it is a potential difference that develops between an electrode and electrolyte half cell ama dai khoi mamang da tamme electrolyte amaga electrode amaga yauni na hariba electrolyte amadi electrode ani sigi marakta leiriba potential difference to madumangni aikhoina electrode potential hainari se it may also be regarded as the tendency of the electrode to lose or gain electrons when it is in contact with a solution of its own ions. That means the electrolyte. Karigumbai khoina hariba potential difference asi temperature na 298 Kelvin. Aduga concentration na 1 molar da on bataragadi that electrode potential itself is called standard electrode potential E naught. Hajik hariba electrode potential si makhal ani thoi oxidation potential amadi reduction potential laidana akoina tamkhre oxidation reduction na electron loction mangamagi tendency amadi electron pithopa ngamagi tendency maduni akoina in terms of reduction and oxidation the naina kibado then for an electrode amagidi electrode same electrode amagida hariba oxidation potential amadi reduction potential animak se value managani tawudabu sign the opposite oigani khudamoina hairabada standard reduction potential of copper machina plus 0.34 volts oiba matamda hariba copper si makki standard oxidation potential di minus 0.34 volts oigani. Then cell EMF natraga EMF of a cell EMF haibadi electromotive force haibani the EMF of a cell is defined as the difference in electrode potential when no current flows through the cell. The EMF of a cell is positive karmatamda if electrons flow from left to right in the external circuit. Akoina hana naina kre left electron si electron risk oiba electron ni masibo koini anode haina khangnai haiba anode sida kaidawi oxidation sathai right electrode sibuna akoina electron deficient electrode oina longnai masibo cathode kawi amadi haiba cathode asida reduction sathai amusu electrons flow from anode having lower reduction potential towards cathode having higher reduction potential. Adoidi hairiba anode tagi cathode chenba matam sida cell adugi EMF ti kamai phangni cell EMF equals electrode potential of cathode minus electrode potential of anode. Haibidi E cell equals E cathode minus E anode. And the standard condition sadadi akoi kari hayani E naught cell equals E naught cathode minus E naught anode. Hauji akoi EMF amadi cell potential ani sigi difference to among yengsi EMF asi akoina hamamang su hai kre it is difference in electrode potential when no current flows throughout the cell. Potential difference haraganamu. It is the difference in the electrode potential when current is flowing through the cell. EMF asinamu. It is the maximum voltage which can be obtained from the cell, whereas potential difference is less than the maximum voltage which can be obtained from the cell. And we should know that EMF is responsible for flow of the steady current, whereas potential difference is not responsible for the flow of the steady current. EMF, it can be measured by a potentiometer, whereas potential difference can be measured by a voltmeter. Ngasigidi matang asi phauba tauba tare walauba sing asina amu mathangida amu ekhoi kumna khangnadaba nainarasi.